box plot showing the worth in billions for our female billionaires and our male billionaires. We have, of course, the count of the female billionaires and male billionaires, which is not very clear in this graph, but we can see quite clearly that our male billionaires are approximately 3 times of a higher number than our female billionaires. And the sum of billions of our male billionaires is much more higher than the one of female billionaires. Now, for the married couple, the number of married couple is 3, and this is why we can't see it on the graph. Yeah. The second box plot shows the worth in billions of each company sector, and we were quite surprised by some of the numbers that some of the company sectors show. As for alcohol, for example, which we expected to show quite a high number, but it is actually the lowest number of our 5 chosen company sectors.
Now, when looking at the numerical data, we perform different type of analysis. So first of all, we use count, sum, min, and max, and we use them to calculate the range. Afterwards, we use mean, median, and mode, which we use to represent the central tendency of the data. And finally, we used standard deviation, quartile 1, quartile 2, and interquartile range, and we use them to represent the dispersion of the data. So here we chose wealth worth in billions with genders, and we chose them to see how the wealth distributions are between the genders. And we wanted to see if they reflect any kind of inequality. And yes, they do. Like in general, looking at all the calculations, we can see there's a big difference between their wealth, as we can see it, for example, in the sum, where we can see the difference where women have almost 9 times less wealth worth in billions in average comparing to men. But there was one calculation where we can see it in the mode, where we can see that for all genders, the value given is 1 billion, which is the lowest wealth at which one individual could appear in the Forbes list. Now, for the sampling, we selected the demographics gender and demographics age. As we mentioned before, the majority of billionaires inherited their wealth, meaning that they became billionaires when they were born. This resulted in them showing a zero value for the demographics age variable. Therefore, to make sure that our analysis and sampling were more representative, we chose to filter the demographics age by taking out the zeros. So now to proceed with the sampling, we first filter our demographics gender by just selecting males. Then we copy and pasted the demographics age into a new sheet. We used the random formula so that we gave a random number from 0 to 1 to each value. Then copy and pasted the whole column so that we ensure that those values won't move, and then went to sort and filter, and then sort by the random values. So now we give a random order for all values. We would do the exact same procedure for females, and then we would select the first 50 values for each gender, and then we had completed our random sampling. Now, for our significance testing, we first created our hypothesis. So, our null hypothesis was that on average, women and men became billionaires at the same age, while our alternative hypothesis was that on average, men were older than women when they became billionaires. So, first of all, because we observed our samples, and as they only consisted on 50 observations, we found them too weak to actually perform a z-test. So we knew that we were going to perform a t-test, but to know which type of t-test we needed to use depending on the variances, we first performed an f-test. So now when looking at the results that the f-test gave us, right now in the means we can already observe that there wasn't a significant difference, and now when looking at the p-value, we can see that it's higher than 0.05. By this, we couldn't reject our null hypothesis. So this showed again that on average, both genders became billionaires at the same age. So now, knowing that our null hypothesis couldn't be rejected, now we knew that we needed to use the t-test, assuming equal variances. So now we're looking again at the results. We again find that the p-value is higher than 0.05, and even showing that it's higher than in the f-test, concluding that our null hypothesis is really likely to happen. Now, to perform the ANOVA test, we needed a third sample. So we decided to change the variables, and now we'll be testing the wealth worth in billions across all genders, so across women, men, but also married couples. And again, look at any significance difference between the genders. So now our null hypothesis is that on average, all genders had the same wealth worth in billions, while our alternative hypothesis is that on average, men have more wealth worth in billions than women and married couples. So we perform sampling again for the three genders. However, when looking at the married couple, we could only observe three values, but it didn't seem to be a problem when performing the ANOVA test. So then we selected the ANOVA single factor test, and then we were looking at the results, and then again we could see that the p-value was higher than 0.05, but also that f critical was higher than f. So again, even if we are testing different variables with a different test, we encounter the same problem. We can't reject our null hypothesis, meaning that on average, all genders had the same wealth worth in billions.
So, in conclusion, we looked at the billionaires data set where we performed descriptive statistics, sampling, and significance testing. Now, some of the key findings we found were the inequalities between the genders, which was mainly the distribution for men and women in the list. Now, we could observe that there were a lot more men on the list than women. Next, even if we used different variables for the different tests, we encountered the problem that we couldn't reject our null hypothesis in any of the cases. And lastly, as mentioned before, inherited wealth was the predominant type, meaning that most of the people inside the lists became billionaires when they were born. And even if we found this very interesting, we decided to filter the demographic age variable by taking out those zeros so that we can ensure our analysis and tests were more representative. And lastly, thank you for listening to our presentation. We hope you got a little bit of insight into the billionaires movements among the world. Thank you very much.